Hello. Okay, today we're going to talk about a few things to elaborate on the last class. I'm going to show a typical function. Then I'm going to talk briefly, go on a side trip to talk about setting options, otherwise side effects, and changing your environment, computing environment. So I'll talk about par and options. And not that I'm going to do our profile file, but I'll show you what our profile file is. And then we'll look at, in that context, the on-exit, why we'd ever want to use an on-exit, which was mentioned in the text or in class. I will also then discuss a couple special kinds of functions, infix functions, how to write those. So just a very slight change of the regular type of function. And we'll look at replacement type functions and the ... how to use that in a function. Okay, so let's start. Go way up here. It's a typical function before we do anything else. We're getting pretty used to these by now. My fun. It's going to be a function. It'll have a variable x. It'll have a variable y with a default of 1. Did I say variable? What I meant to say was argument. Argument. And an argument called check. Hey, if check, I'll actually have it check something. If x is negative, we'll have it stop and complain loudly. Yeah, I think negative x is bad. Gets at it, basically. Okay, we'll take x to the power of y. And then, so basically what happens in the function, here's the formals, the argument that goes into it. Here's the body. When you reach the end of the body, I wrote things into something called out, and since that's going to be the last line of our function, that's what's going to be output. So let's see what happens. My fun. Let's say when you I'll do this by position first. So when x is 1, y is 1, we get, how about when x is minus 1? Uh-oh, it checks it by default. I could say check equals false, turn that checking off, and it just then applies the function. Look at that, I can get away with just saying 2, it's going to bring it to the first power, and it's going to check it. Yeah. So that's pretty much how a function works. Now that was what's called a pure function. Well, yeah. A pure function because it didn't have any side effects. It did not change the environment. So as soon as that function was over, other than printing out its error message, and whatever output came out of it, it did not permanently set anything. It did not change how my graphics works. It didn't leave any plots open. Now, obviously, some things are supposed to have side effects. It'd be kind of worthless to have a quit that didn't have a side effect. How many people actually store something from quit? That wouldn't really work, would it? Things like library, which attach a library, that function is one that is all side effect. It attaches a package into the sequence of environments, search path up there. So now let's see what's going on right here. Ooh, look at all the stuff that's have been loaded in here. Okay. Guess I just attached a bunch of packages by attaching GOR. I wonder if that has any output. A lot of these functions have output. Oh, it does. It does. There's a list of the attached base packages. Is that just a list of the packages as output? So these work like regular functions. Typically something comes out of them, but it's really the side effect that people want. Now, talking about side effects, The two biggest set of side effects come from options. Let's look at the list of options here. Whoa, there's a lot. Options set all sorts of things. How our error messages work, how long digits are, whether we go into some sort of debugger when something goes wrong. Echoes, editors, chooses the default editor. Paper sizes. So there's lots of things to change. If we want to change one, which might be not a great idea, there's you can set options by saying things like, oh well, I can get an option, so is there one called error? Oops, no errors. Okay, there. There isn't an option page size? Wait a second. Probably misnamed it. Page. No, paper size. Okay, there we go. Default paper size is A4. There we go, A4. So I actually could set that. I could go options, paper size equals, but you know, I'm just going to say A4 and leave it the way it is because I don't really want to mess with options. Now if I set an option, that would be a side effect because from then on it would do whatever I say for my option. So I can even do things like reset the prompts. I don't know if I want to do that. I feel like I'm going to cause a disaster. But let's do it anyway. Hey, I want this for a prompt. It's going to say R every time. Oh, look at that. Help. See? Now instead of the less than or greater than sign, it gives an R for the prompt. I don't really want that. I think I'll go back to the old prompt. Here we go. Did that do it? There, much better. One that's really nice is, well, let me show you a bunch of these. So one thing I can do is I can set these right at the beginning as I'm programming. The same thing goes with par. Par are all graphics parameters. So, oops. Open the graphics window while I do that. But here are the list of graphics parameters that can be set. And we'll stick around once I set them. So CEX, the size of default size of points, axes sizes, writing sizes, colors of labels, all sorts of things for the plot command. So these are lots and lots and lots. Here's one of my favorites, LWD, line width. How bold the lines are. I can actually do something with that with a little bit of fear. So what is the line width default is 1. I could set it. Now once I've set it to 3, look at that. When I do a plot, I have changed the environment. So look at that. Oof. Very bold. Let's see. However, I might not actually want to do that. Let me set it back. And we'll get to the point of doing that in just a second. So we notice we have the options and we have par where we can set environment. In fact, some people are kind of fancy and they want to set a bunch of things that happen on startup. I'll tell you how you do that in the Mac, and then I'll tell you why not to do it. Well, one thing, if you start setting these options and then you do work, if you share your work with anyone and they don't set all their options the same way, they're going to get different output on their computer. So in some ways, it's nice to wipe out everything. By the way, I'm just going to wipe out everything in my, my global environment. So let's see what's in my global environment. Nothing. Okay, good. All right. So, but there is this one thing. I can write a file, and I'll show you one of these. These are called an R profile. Here it is right here. This looks like it. Oh, I better make it teeny bit smaller. Eek. We'll get that. So I've commented almost everything out in this before I try it out. But what you can do is you can set lots of things like paper sizes. You want significant stars on your regression output. You can set seeds so that your random number generators work the same way all the time with the same starting seed. You can set your prompts. This is the string as factors. Remember when you read in data frames, it converts strings into factors by default. This can stop it from doing it ever. So this is essentially going to be a file, a startup file, that when you sign into R, if you do one called a R profile file, you'll have things work when you start up. So we could set our environment. That's making the history, how far I could go back, really huge. I'm setting the tabs. I can set the width of the lines. First is a bunch of things that happen as soon as you sign on. For instance, I can pull in packages that I always use. I can create aliases. Here's some aliases here, renaming some variables. I don't know if that's a good idea. Oh, not variables. Functions. So summary inside the base package, head inside the utilities package, names inside the base package. I can abbreviate those if I use them a lot. I can redefine quit to never save workspace. I can have it say when people sign on, R, a pirate welcome at whatever date. Same thing down here, last, shows what happens when you have sign off. It can say avast ye, prepare to sign off on, and then there's a date, and that's that. So that's really how an R profile works. If you Google them online, well, where else would you Google them? In the street? You'll find under R profiles, you'll see lots of people, Stack Exchange and so on, people discussing all sorts of interesting functions they use in their R profile to customize their work environment. So that gives an example of options, and I didn't do any par functions here, but okay. And just to show you, in the Mac, they each have a spot. Things have a spot where they belong. And our working directory, where it looks for things, is going to be the user Ron. There it is right there. So the truth is, how you get these files is you write them as a text file, and then you save them inside directory user Ron as a text file, and then copy them into a file called .r profile. And a dot file are usually operating system, well, they're often operating system files. Do not touch them. And they're invisible files. You don't see them when you peek inside the folders, but I'll show you how you find them. This is just Mac. And in fact, I encourage you not to do this because, look, we don't want fragile systems that are highly dependent on what defaults you set. So I'm going to go in my utilities, hit terminal. Ooh, that frightening terminal. And hey, it opened up in the directory, user Ron directory. I can take, this is so Linux-like, it's exciting, isn't it? LS here also, and here's some files in there. Oops, I want to see invisible ones. There we go. This includes invisible ones with dots at the front. But the key one is there's this file here that's rprofile.r. .text, which is just, you copy a text file with your profile in it. It looks like that. Pretty exciting, huh? But that's not really the format it has to be in. So then you copy it in the same directory into a .r profile file. And then that's where your R will first look to look for a profile. So, and get startup sort of thing. So, but I pretty much commented everything out of existence. In fact, I'm going to erase it before I sign on, but I'll show you it's there. Let's see. If I just say ls, I won't see it. No. But I think it's there. Right. Wait a second. Where is it? It's our profile.text. Didn't I just copy that up here? Our profile. Oh, there it is, right there. Okay. Yep, all is well with the world. There it is, waiting. So I'm getting rid of it, by the way. So there. Please don't erase random dot files, really. Unless you do lots of backups. Oh well, let's see. Oop. Oh, exit, right? That's it. Alrighty, so there I am outside the terminal. Okay, so what's this all leading to? That's the use of the on exit. What happens is inside, basically you use the on exit to when you start up something in a function. Let's go. Get option. Okay, yeah. Oh, please don't break anything, Ron. Okay, I can save a state when you're coming in. I'll call it old par. Okay, so all the writable parameters in par are going to get saved in old par, and I'm going to restore them once I do something. So I could do this, and then you have blah 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 blah. You can set par now. Okay. Then you can do like a plot. Without doing line width, because I've set the environment. In fact, I could do lots and lots of plots and all sorts of things, and the thick line width will go on the whole time. And then when I'm ready, somewhere in there, I do an on exit. And what that does is oops. Let's just do old par and reset them all back to the beginning. Okay. Let's see what happens. Oh, there's a function there. Ooh, look at it. It's drawn really darkly. Ugh. Well, that was annoying. Hold on. I should pay attention to what I'm doing. But, you know, it's late. There we go. There we go. Okay. So, now if I run new fun. Uh-oh. I don't want to see what's in it. I mean, I could look at formals and so on. Doesn't have any formals. Does it have a body? Better. Though a command hide the body would be excellent. Okay, where was I? Look, it's in the global environment. Okay, so new fun. There you go. You get your dark graph. Now if a miracle happened and everything worked right, if I do a plot again, aha, look, line width is back where it was. So I've restored all my environment settings. So if you had a really long function with lots and lots of plotting, you can set options and you can set graphics parameters at the beginning of the function, and then but before that, save the status of your different parts. Let me show you another one with onExit. Okay, let's look at a little exciting function. Out of K. Okay. Here's another one. Start with a function there. Here's a super duper, just brilliant function that if you have a vector x, let's go 1 through 5. What's this function do? It's going to have output, and it's going to take the kth item and convert it to infinity. So the third item will be infinity. Yeah. Okay. But what happens if you try to do something funny like, well, funny is not the right word. Now that had 5 spots, so what if I go to the 8th spot? Ooh, look at that. It's really neat. It tries to write in the 8th spot, which means it dynamically extends the vector all the way to the 8th spot, filling it with missings. Well, it happily runs, and I might want an error to come out. Okay. One way I could do this is by putting error messages actually inside the program, but another one, if I want to make more elaborations on the checking, because R automatically checks lots of things, and options can get at that. So there's one that checks mounds. So let's see. Oh, look, it doesn't check bounds. So what I'm going to do is I'm going to reset that option. Instead of resetting it in my environment, I'm going to have it formally check bounds. Mind you, it could do this for, if I really like this, I could slip it into an R profile, or at least set my options when I first go into R. Well, let's take a look at this thing. So we've got a new thing. I've set options check bounds as true. Now let's see what it does. Hint, it does better checking a bounds. So I do X and I replace the 8th one. It says that. It actually, notice, instead of extending it, it also gave me a warning message automatically. And out K equaled infinite assignment outside the vector. Okay. It still extended it, but it gave me a warning. So that's pretty nice. But the trouble is, once I've done that, I've permanently changed. Well, let me see. Uh-oh, I've set it to be true all the time. Okay, so what could I do instead? Well, to really sew things up, I should cut it out, because look, even if I try a new one, 1 through 3, y of 6 equals inf. Okay, I still get that warning message because this has a side effect. So essentially, this function which I changed to give snappier error messages, now has modified what happens in the global environment, which would be really bad if I lent this program to someone, because it's permanently changed what's happening outside. Okay. In fact, I think the only thing to say in something like that is that's basically Nicolas Cage. You always need a, critical Nicolas Cage quote in the middle of your analysis. Okay, so what I'm going to do instead, let me pretend that I had it set to whatever the default was. I'll just go check. So if I had just started, I would have this situation. So let's say instead I wrote the function this way with an onExit. Notice what it does here. We go into there. We're going to say check bounds old, which is going to save the old status of check bounds. So whatever the user set it at before, or whatever the default is, it's going to get that state when it enters the program, or function, and then it's going to, when it exits, reset it to what it was at the beginning. Now I can set it to true, run my program without damaging what happens after it's run. Okay, now let's look at y of 8. Oop. Okay, no error message. It did do the extension still, but it didn't flag the error message because I used the onExit. Okay, so in other words, onExits can be used when you want to set global levels, possible side effects, and you want to revert back. And the nice thing is, most of the time, if your function stops prematurely, it'll still run the onExit function. Let's talk about really quickly two other functions. They're really the same type of function, just how you write them. So let's look at infix functions. That's when we've used infix all the time. Infix, like 4 plus 5, is actually a function. It's a function called plus. Let's look at that. 4 comma 5. See, so we can always write an infix function this way. Oh, I wonder what times looks like. Or not too exciting. Let's do power. Oh, wow, 2 to the third power. So in other words, you could write them as regular looking functions. But instead, if we want to create an infix operator, you use percentage, let's see, a function name operator, and then another one. So let's say one thing, I'll do a little quasi teeny bit of an R package. Not really, but let's say I want to create a vector of size 2 with integers either 0, 1, 2, or 3 in each slot, and I want to create those. It's going to be a group, so I'm creating an object. Let me show you. So I'm going to first write a function called asGroupElement. This is going to be called a group element. This is a function that's going to allow me to put a vector of size 2. Alas, I didn't check it, but x, the input has to be a vector of two integers. Okay. And well, if they were numeric, they get converted to integers here. Then they're taken each of the two mod 3, and they're given a class name, so an attribute class is set, and then their output. So what this does is something like this: as group 1, 1 looks like comes out like that. Okay. Okay, notice it's the vector 1, 1 and it has a class attached to it, or 1, 2. Okay. Let me create a couple of those. There's two objects from that group. Okay. Well, that's kind of ugly the way it prints out. So second statement I might make, that's a very common one, is a generic. Well, okay, it's going to be a method. So I'll take a generic and I will create something called print.group method, group element. What this will do is, if I say print, if I invoke print, it's going to look at the object that I'm printing, and if my object's a group element, it's going to go here and print this in this specific way. Bracket, first integer, comma, second integer, bracket, and a return. So let's go. So I could invoke it several ways. This is the long, boring way, lm1. There you go. You could get that. It should be smart enough, let's see, to do it if I just say print, because it's a generic. So it's going to say, hey, this is a print. Ooh, this is a group element. Hey, I'll go to the function group print.group element, and I'll invoke the printing. In fact, now it should even work here, because if you just type something in return, you invoke print. So I've created a way to print these. So I can create them. I can see what they look like. Another thing that's often very handy is to make a generic is function that checks all the things to make sure it's really a legal version of that. Notice it's going to say, is it integer? Is its class set to group element? Is its length 2? Is everything less than 4 and everything greater or equal to 0? If all those are true, it comes out true, otherwise false. So let's hope this worked. Is group element of lm1. Whoa, it is a group element. What if I do it for something that's not one of these group elements, just a vector? Oh, nope, that's not a group element. But lm2 is a group element. So far I've made a function that creates, instantiates these objects and gives them a class. Something that prints them, and I have something that checks them. Now I might want something that adds them together. So let's look at how I'll do that. I want it to add together like a pluses add together. So I'll create one. I'll do parentheses plus parentheses. Percentage plus percentage in quotes. Function's going to be a function of two things. That's how infix works. And if they're both group elements, if they're not group elements, it's going to yell at you. Okay. Otherwise, it adds them together and takes them mod 3, sets the class of this output to group elements, and that's your output. Let's take a look what happens when we do that. So we have lm1. So that's all infix is. It's just a special kind of function of two variables. lm1 plus 2. Oh, not dollar signs. Yay! Look at that. Pretty snappy, huh? I hope it actually worked. Let's see, lm1, lm2. It's 1, 2. 1 plus 2 mod 3 is 0. 2 plus 2 mod 3 is 1. By gosh. It seems to have worked. Let's try one last one. Oh, yep, not a surprise. Okay, so that's an infix operator. And again, it's just a type of function. That looks kind of neat. Here's another one, replacement functions. We've seen a few of those. It's when you, normally we have to say if we want to operate on something, let's say we have something like x, and we want to double everything in x, we have to say x times 2, or some sort of function of x, and then we have to have an equal here to assign it to x. So what that's going to do, because if I just say x times 2, it'll double x, but x hasn't changed because functions work on copies of the arguments. So this essentially takes a copy of x, doubles everything in it, and that's your output of that function, which is multiply. It's really this function if you think about it. x2. Yep. So, wonder if that has formals or is it a primitive? I should have asked. Oh, yep. Not surprised. You know, if multiplication isn't primitive, I don't know what. Oh, hold on. It's not. Oh, because it's a method. Okay. Sorry. I mean generic, almost certainly. So, because it operates on lots of different types of objects. No, I won't even look. Okay, so the idea is, typically if you want something to be right over itself, you have to do this. You have to actually do the computation and then have it right on x. Ooh, I wonder if it changes place. Oop. Oh no, add. Oh. No. I don't know why that's not coming up. Okay. Sorry. I won't do that right now. So, replacement function. So instead of having to do that, like x times 2 to double it, oops. Now I have changed x. You can kind of do that formally by making a function that seems to operate on x and right over x at the same time. So I could write a function called double. And these replacement functions look like this. Put in double. Doubling, I better call it, because I don't want to mess things up. And then you put this. Okay. As soon as it sees that, it's going to say, aha, that's a replacement function. And then you write just function of the object name and then what's assigned. No. Doubling. Multiplying. Let's call that multiplying. I want to be more generic than just more general, I mean. Okay, so we have x and a value. Okay, so we want to take x in, and let's do an output. Looks like a regular old function there, doesn't it? But this is how we can use it. So we could say, okay, and then it will double it. But you can instead say this. Watch this. So kind of like those class commands and a few others like that, comment command and so on. We can say multiply by, and then we have our x has now been tripled. So notice when you write it when you write a replacement function and invoke it this way, it's going to take 3 times the x and immediately rewrite over the x to give you 3 times it. So let me look at another one that can work this way. Here's one that's not quite as idiotic as that one. This one's lengthen. Here's a function. What it does is it takes a list. So this is really supposed to work on a list. I ought to check that it's a list, but I didn't. So it's a function that's a list and a value, and what it's going to do is append as a new list element that value. So it takes the length of the list, then it appends a new object to the very end of it, and then that's your output. let's see how that's going to work. Let's make a list. Okay. There's a list right there. Ooh. Okay. No names attached to it. Got it. So let's, oh no, names of X, there's the names. Yeah, none to the first thing, A to the second, and none to the third. Sorry about that. A little late here. So if I use lengthen, I could say X by adding, what do we want to add? Let's add hello world to the end of that list. So when I hit return with a replacement function, it's going to append that to the end of it. Let's take a look. Yeah, exciting, huh? Okay. So really, it's things you could do just with a regular old function, but they're kind of snappy. All right, one last thing that was mentioned in the last class was ... I'm not going to talk about closures because this is getting a little long already. ... What is that used for? It's to pass an indeterminate list of, it really is going to end up a list, but a sequence of functions that you don't want to name ahead of time. So let's say we have a function that you can pass either X or ... to. Okay, so X is going to be an argument it has to have, and ... So let's say that's a vector, and ... is just a list of, or several functions that aren't X. Okay. Now, one way to use ... is to, just inside a command, you can say ... and that will make all the arguments they put here will go inside this function. So it's a way for them to pass lots of graphical parameters to plots and such, contours. That's why a lot of times when there's anything that makes a picture in R, you can desperately try to just put general plotting commands into some of its arguments and just see if they work. A lot of times they will be passed down to do what you hope they do. So that's one thing that can happen. You could, if you want to do something with those ... you can convert them to a list, and then you can pull pieces out of them or whatever you want to do. Or it turns out you can get parts of them. The first item in there, in that sequence, the first argument that's given is going to be called ... The second one's going to be called ... and so on. So there's a variety of ways to get at ... that are passed in. So let's go newer fun. I'll put in 1, 3, 4, I'll do nothing but that, and I get a graph. Not too exciting. But I can pass graphics parameters to that. Let's go. Okay. I increased the size of points. Notice when it did all these other things, it did the plot just fine. Internally, it created that. It shows you what the list is. Okay, it was CEX3. Printed the first thing in there, which was 3. There was only one argument, but there wasn't a second argument right there. So it complained here that it couldn't print out the second argument because I only gave one extra argument. Let's go add another argument. Ooh, there we go. Made our line width 4. Notice that gets passed to the plot. Now our When we convert to a list, it has both CEX and line width. The CEX, the first one is 3, the second one was 4. This is just what I asked for here. Okay. And then I can keep adding them on all I want. So PCH is 19. Aspect, I don't know if aspect's going to do anything for us. Oh, there we go. Okay, spacing on the left and the right are the same. Nice big dots. Even I can see them. So that's all dot 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 is good for. They're not just for plotting. So sometimes when you want to just operate on a list of arguments. Oh, what did I just do here? Oh. So if I'm going to do that, and I'm not going to pass it to a plotting function, but I actually just want to, for instance, bind together several columns, I can go that'll convert to a list. I can see how many things are in the list. I can print the list. But then I can do something like, what would be an interesting thing to do with the list? Yeah, well, now that I've bound them into a list, I could convert them all. Well, I'll just put them out as a list. Okay, that'll attach several different arguments together. So I go new out, and then I can say things like x is C1, 2, 3, y is C3, 3. We'll put in another column, 1, 1, 1. Okay. What comes out of it? Here's I save the list. Okay, convert it to a list. I look at the number of arguments, which I don't show, but then I print the arguments, and here they are. X, Y, and the third one, and then out it comes as a list. So basically, that's really, I rewrote the function list, so that's not very thrilling at all. Woo! It converted those three things into a list.